Now just here. So what is an ammeter? Is a device which is used to measure the current. Ammeter, because current is measured in amperes. An ammeter is a device which is used to measure the current. What do you use to construct an ammeter? We use galvanometer. What is the meaning of galvanometer? See, galvanometer is a device in which when the current passes, it will show the deflection. Galvanometer is a device. Okay. So here, galvanometer is a device having very high resistance. But we have to use this galvanometer and construct one ammeter. An ammeter is a device which is used to measure the current. Current is measured only when it is allowed to go inside, no? But it is high resistance, it is not listening to me, it does not allow the current, then what will you do? I will add a small shunt resistance parallel to the galvanometer. Shunt, only 1 ohm shows a much difference. How much difference? Now these two are parallel. So R parallel is equal to G into S by G plus S. R1 R2 by R1 plus R2. So resistance parallel 100 into 1 by 100 plus 1, which is 100 by 101, which is less than 0, which is less than 1. See how we are doing. We are shunting it by adding a very 1 ohm small resistance. 100 ohms, when you connect just 1 ohm, 100 ohms has been reduced to 0.9 ohms. That is called as shunting. So now the total resistance in the circuit is less than 1 ohm. So this current which is passing here. So first of all, you try to understand that. Now this combination combined together, having one galvanometer connected one shunt parallel to it, is combined together called as an ammeter. This combination is called as ammeter. So here, if you observe that, if the current passes through the ammeter is I, so how much current passes through this? The current passes through this is Ig. I'm not talking. Okay, so what is the current passing through here? Which is I minus Ig. Okay, the current passes through the galvanometer is I, means the remaining current passing through the galvanometer is how much? I minus Ig. And this I minus Ig is called as Is, which is passing through the shunt resistance. So current gets divided. Some of the current passes through galvanometer, some of the current passes through shunter, and that is called as Is, which is taken as I minus Ig. So as this is a parallel connection, the potential connected across this is going to be same. So in the parallel connection, the potential is going to be same. Whenever you connect something parallel, the potential across the shunt, the potential across the galvanometer is going to be same. So potential across the shunt, potential across the galvanometer is going to be same, isn't it? So what is going to happen now? Potential across the shunt is nothing but current across the shunt into shunt resistance, and potential across the galvanometer is nothing but galvanometer resistance into G, because general formula is V is equal to IR, I into resistance, IS into shunt resistance, IG into galvanometer resistance, isn't it? That's it, is it? So how much shunt we have to connect here? Because you all know I is nothing but I minus Ig into shunt is nothing but Ig into G. Okay, so this is called as shunt resistance. Shunt is nothing but Ig by I minus Ig into G, which is S is equal to G in the numerator. This G comes to denominator, I minus Ig by Ig, okay, which is nothing but G. So this is partially, if you divide, it becomes I by Ig minus Ig by Ig is going to be 1. So therefore S is equal to G by N minus 1, where N is nothing but the ratio of total current by the current across the galvanometer. That is called as N. So what is this formula representing here? This formula represents that how much shunt resistance we are connecting to the galvanometer. Understood? The question will come here. What should be the shunt resistance connected to the galvanometer so that it can measure the current? It can measure the current between the range 10 amperes to 100 amperes. You have to connect, you have to construct one ammeter whose range is from 10 amperes to 100 amperes. Means what? How much shunt is connected to this galvanometer so that your ammeter works, which can measure from 10 amperes to 100 amperes. See, 100 amperes means I now. Okay, in this galvanometer, if you want to find out the shunt, you should know what is I, you should know what is Ig. See, Ig means how much current passes through galvanometer. See, galvanometer is high resistance, this is low. That means very less current passes through the galvanometer, maximum current passes through the shunt. By using this formula, you can get how much shunt resistance should be connected. For that, you should know what is the galvanometer resistance. You should know I means 100 meters, which is the maximum range. IG means minimum range. Understood? 10. So minus 1. By using this, you can find out the shunt now, which is 100 is the galvanometer resistance. I is 100 by, and the lower one IG passing through this how much? See? Understood? Okay? 10. So 10 minus 1, that's it. You get shunt resistance corrected. Hope you are understanding what I am saying now. So this is the first concept where you will find out how much shunt is connected to the galvanometer so that its resistance reduces. That is the meaning of shunt here. Shunt means always connecting one resistance parallel to the galvanometer so that it can be converted into ammeter. Is it clear what I am saying now? So after that, the next concept is here. If this is a galvanometer having one galvanometer resistance and is having a shunt resistance connected in parallel. So what is the current passing through the shunt? Is. What is the current passing through the galvanometer? Ig. And here, this is called as the net potential, which is the total potential here. Okay. So total potential here will be equal to potential across the shunt, which is also equal to potential across the galvanometer. Because in always parallel connection, potential is going to be same. Potential is going to be same. Only current gets divided. I is divided into Ig and Is, I told you it is nothing but I minus Ig. Hope you understand now. So what is the total resistance in this galvanometer? I told you the net resistance across the galvanometer is they are connected parallelly. No, it is taken as R1 R2 by R1 plus R2. It is G into S by G plus S is going to be the net resistance, isn't it? Now, what is the net current? See here, first of all you compare potential, net potential and potential across the shunt, then you will get what is Is. How much current is passing through the shunt, he asked in the question. Okay, how much current passes through the shunt, he asked the question. Then you have to find out Is, you should know what is the net potential, you should know what is the potential across the shunt here. So net potential means net current. And net resistance also R net, which is nothing but this is called as R net here. Okay, so I into R net is nothing but Is into S, which is nothing but V is equal to IR, general formula. I into R net, Is into shunt resistance. This is also resistance, that is also resistance. In the place of R here, yes, in the place of R here it is G. That's it, isn't it? So you will find out what is I into R net is nothing but GS by G plus S. Which is nothing but Is into, which is nothing but Is into S. So S gets cancelled. So if you want to find out the shunt current passing through the shunt resistance, the simple formula is you should know what is the total current and you should know what is the galvanometer current, G plus S. Okay. So this is the formula to find out the shunt current and across the shunt resistance. So simple it is. Next. Okay. The next thing is same galvanometer resistance which is connected to the parallel, which is called as shunt. So this is the Ig, total current is I and this is Is. Now you know the net potential connected here is going to be V. That V is equal to Vg and that V is equal to Vs. Now I am asking what is the galvanometer current. Now the second case is I want how much is going to be the galvanometer current. So to find out the galvanometer current, compare the galvanometer voltage which is always equal to the total voltage. Yeah, because they are connected in parallel, isn't it? So Vg is equal to V. So Ig into G, because V is equal to how much? The general formula is V is equal to I into R according to Ohm's law. So Ig into G. This is I, total current, by R net, total resistance there. Total resistance as they are connected in parallel, R1 R2 by R1 plus R2 is nothing but G into S by G plus S. Hope you are understanding now. So I, if you want G, Ig into G is equal to I. R net is nothing but Gs by G plus S. G gets cancelled. Ig is nothing but G into S by G plus S is going to be your total galvanometer current. Yeah. So I into S by G plus S. Very simple here. If you want to find out the galvanometer current, multiply total current with total resistance. But G, if you want to find out, G will not be here. G, Ig, if you want to find out, G will not be here. If you want to find out, S will not be here. But denominator consists of total resistance. Here it is only complete current. So this is a total story of an ammeter. So simple it is.